Okay, so 4.2, coterminal and related angles. So let xy be the point on the terminal arm of an angle theta in standard position. Okay, so as a review, standard position is when we start at the origin and we have our initial arm, which is the x-axis. Okay, and then we rotate up, see this arrow, we rotate up, and then this is going to be our terminal arm. Okay, so if we have some point x comma y, well, we know that we want x amount of units to the right, y amount of units up. Okay, and then what we're actually dealing with is the radius, because remember, if we rotated this line in a circle, this would be the radius from the center of the circle to any point on the circle. Okay, so as a recall, the side opposite theta is going to be y because it's up and down. Okay, so this is opposite. The side adjacent to theta is going to be x. Okay, and the r is always going to be the hypotenuse. We can also find r using Pythagorean's theorem. Okay, so we have sine, cosine, tan, the ratios here. So let's do a hands-on example. Like, how would this look in a question? Okay, so the point 5,2 is on the terminal arm of an angle theta in standard position. So 1, 2, 3, 4, 5, because remember, this is x comma y. 1, 2. Okay, so we have some point here. This is going to be theta. Find the exact ratios of sine, cosine, tan. So we would draw it like this. Okay, 5 would be here, 2 would be up here, and we don't know what the radius is, but we're able to find it using Pythagorean's theorem. So the radius is just going to be, for example, x squared plus y squared. If you take a look at this, this is also the equation of a circle from grade 10. Okay, so the x is 5, so 5 squared plus 2 squared. We get 25 plus 4, so we get 29. Okay, we don't want r squared, we just want r. So if we take the 29 and we root it, we get let's go 5.4. So this is 5.4. Okay, now let's just write out the ratios. So sine is going to be opposite over hypotenuse. So we're going to get 2 over 5.4. Adjacent over hypotenuse is cos, so we're going to get 5 over 5.4. And tan is going to be opposite over adjacent, 2 over 5. And for the scope of this course, I am okay with you leaving the denominators as decimals. Okay, if you did want to convert, you would multiply both by, say, 10. So I'd get 20 over 54. And then you would just have to reduce. So 20 over 54 equals 10 over 27. Okay, it's mathematically correct to express fractions as integer values. So this would be like 50 over 54. And then we would get 25 over 27. And for this one, I'm just simply using my ABC button, and it's reducing for me. Okay, the point -4,3 is on the terminal arm of angle theta in standard position. So let's go x comma y, 1, 2, 3, 4. So this is going to be -4. Okay, and 1, 2, 3. So we're going to have this as our terminal arm. Okay, and we always draw our angle down to the x-axis. So this is going to be theta. Okay, so we have 4 down here and 3 here, and then we have to find our radius. So radius squared equals x squared plus y squared. So our radius is going to be 4 squared plus 3 squared, which is 16 plus 9, which is 25. So our radius, when we root both sides, is just 5. Okay, everyone should be familiar with the 3, 4, 5 triangle. Okay, 3, 4, 5 is a Pythagorean triple. Okay, it works out perfectly with Pythagorean's theorem. So now all we have to do is find the opposite. So let me label. So as per theta, so relative to theta, this side's opposite, this side's adjacent, and this is the hypotenuse. So for sine, we get 3 over 5. For cos, we get 4 over 5. And for tan, we get 3 over 4. Okay, so there's one more step here. Because we're not in quadrant 1, we have to apply the cast rule. So in this quadrant, sine is going to be positive. Cos and tan are both negative. Okay, example 3. The point 5, negative 6 is on the terminal arm of angles theta in standard position. So this is x, this is y. We'll call 1, 2, 3, 4, 5. Okay, so this is 5, comma, negative 6. 1, 2, 3, 4, 5, 6. Okay, so this is going to be negative 6. So this is our terminal arm. We always draw up or down to the x-axis. Okay, so this is going to be our theta. So when we label this, like from here to here, because that's our x, this is going to be 5. Up and down is going to be our 6. And we're going to solve for our radius. Okay, so radius is going to be our x squared plus our y squared. Okay, so we get 25 plus 36 for this one. So we get r squared equals 61. Oh, you know what? Even better idea. I'm going to leave it as r equals root 61. And the reason is because we've covered radicals in this course. So I'm going to label the 6 as opposite, the 5 as adjacent, and the root 61 as hypotenuse. And I'm actually going to sub them in to sine, cos, and tan with like the root 61. So I get 6 over root 61. For cos, I get 5 over root 61, and then I get 6 over 5. Okay, one more step. The cast rule, C-A-S-T. We are in the cos quadrant. So cos is going to be positive. The other two are going to be negative. Okay, theta is an angle in standard position in quadrant 2. So we know that this is quadrant 1, this is quadrant 2. So it's going to look like this. Okay, and then theta is an angle, standard position. Okay, so automatically, just because I know the questions, I'm going to draw this down to the x-axis. Okay, so it's telling us that sine theta equals 12 over 13. Okay, what does that mean to me? That means that the opposite side is 12 and the hypotenuse is 13. So this one's going to be 12 and then this one's going to be 13. Okay, so we don't know what our x is, right? Like our x value here. We know our y is 12. Okay, so first we have to solve for x, and then we're going to use the same numbers and put them into cos and tan. So we know r squared equals x squared plus y squared. Okay, so specifically this 13 has to be the radius. Okay, this one's going to be the hypotenuse. So 13 squared equals 12 squared plus, oh, you know what? I'm going to put this in, x squared. Because this time it does kind of matter because we're calling this x, our x coordinate. Okay, so we get 169 equals x squared plus 144. Let's move this 144 over. Okay, and then what do we get? It's 25, and then we're going to root both sides. We get x equals 5. Okay, so now that we have our opposite, we have our adjacent now, that's what we solve for, and we have our hypotenuse. We can go ahead and we can sub these into cos, which is adjacent over hypotenuse, 5 over 13, and tan, which is opposite, 12 over 13. Last step, let's apply the cast rule. This angle is in the sine quadrant. So sine is going to be positive, which it was. Okay, they gave us that. So now cos is negative and tan is negative. Sorry, this was 5. Okay, tan is opposite over adjacent, so 12 over 5. Okay, coterminal angles, and I know we've touched on this before, angles in standard position that have the same terminal arm. Okay, that's what they are. So for example, if this is the terminal arm, then if we rotate up directly to that terminal arm, that's going to be the same angle as if we rotated around and came back to it, or around again and came back to it. Okay? So example, and we've went through this one before, 0, 90, 180, 270. Well, 360 is going to be coterminal with 0. Okay, that's a very, very common one. So find 3 positive and 3 negative angles that have the same terminal arm as 30 degrees. Okay, so all I'm going to do is take 30, and for the positive ones, I'm going to add 360. Okay, so what's 30 plus 360? Well, it's 390. Okay, well then take our 390, because that's coterminal with 30. Add 360 again. Every time we go around a circle, we are going around 360 degrees. Okay, and then theta 3, 750 plus 360, we're going to get 1110. Okay, so for the positives, we're going to get 390 degrees is coterminal, 750 is coterminal, and 1110 is coterminal. Okay, what about negative angles? So for the first negative angle, we're going to take 30 and we're going to subtract 360 degrees. Okay, and we get negative 330. Now we're going to take that negative 330 and just again subtract 360 degrees. And we get negative 690. Okay, and then for the third theta, for the negatives, we're going to go negative 690. Again, we're going to go around the circle. So we're going to subtract 360 degrees, and we get negative 1050. Okay, so all of these angles here are going to share their terminal arm with 30 degrees. They're all also going to have the same ratios.